Hi everybody, Professor Gusimi here. In this lecture, we're going to discuss how the web works. More specifically, I want to help you understand what the complete technology pipeline and all the associated terminologies for viewing content are in a web browser. While this is not essential to writing web code in the short term, before very long, you're going to benefit from understanding what's happening in the background. So in essence, the internet is really the infrastructure that allows computers to reliably exchange information. So Google is not the internet, but Google uses the internet to send you your search results. Facebook also is not the internet, but Facebook uses the internet to send you social media information. Like most things, the best way to intuitively grasp a concept, in our case the internet, is by way of analogy. And I think the best analogy for the internet is the Postal Service. Because ultimately the goal of the Postal Service and the internet is actually the same thing. They both want to move things from one place to another as quickly and as reliably as possible, albeit there are some differences in their efficacy. In the case of the Postal Service, the goal is to move a physical object from point A to point B without altering it, destroying it, or sending it to the wrong place. In the case of the internet, the goal is the same, except that we want to transport an electrical signal from one place to another without altering it, destroying it, or sending it to the wrong place. Now, let's say you receive a letter from your beloved grandmother asking you to send her a barrel of apples. And you're being a good grandchild and happy to oblige this request, but there are a whole host of detailed rules, protocols, and procedures that have to be followed by both you as well as the Postal Service if you want that barrel of apples to arrive safely at your grandmother's home. If, for instance, you wanted to send the barrel of apples by mail, then you couldn't just roll that barrel of apples into the Postal Service. You would have to first provide the postman with an address that you wanted to send it to. And similarly, if you want to send information using the internet, you need to provide a specific address of the physical machine that you want to send those packets to, aka the Internet Protocol address. Now, some physical locations, of course, have specific names that imply their location without needing a specific address. If you wanted to send some of those apples to the White House, for example, you wouldn't need to provide any further information than that because as long as there's only one location with a special name called the White House, then the Postal Service can look up the address through public records and find out that when you say White House, what you really meant was 1600 Pennsylvania Avenue, Northwest Washington, D.C., 20500. So here too, the internet's similar. One can associate a domain name, example, google.com, that's like the White House in this analogy, to a particular IP address, 64.233.160.0. And as long as that mapping is recorded in a public record system, those record systems are called domain name servers, by the way, and they're essentially keeping a long table that says, hey, this location maps to that address, this location maps to that one, and so on and so forth, just like you would have in a regular record-keeping book. So let's say that you address this package correctly, your barrel of apples correctly, and you hand it off to the Postal Service. And they begin doing their review. And they say, okay, thank you so much. With this address, we're good to go. You hand it off, and the postman then, right as you walk out the door, starts going through their list of procedures. And one thing they notice is that, well, your barrel of apples is far too large for them to just send in the mail. They can't weigh it, they can't package it up, and so on. So first thing they have to do is they take your barrel of apples and they pack it up into smaller boxes, right? And those smaller boxes all get shipped to ultimately your mother's address. Well, just as the post office has these protocols and procedures they use to package the mail, to send it, how big can it be, what's the size of the box, what are the routes, so too does your internet have processes and procedures that it follows to make sure that your things arrive safe and sound. In the case of the internet, this is called the Transmission Control Protocol, or TCP. And among other things, TCP specifies the size of information that you send and what to do to ensure it arrives certifiably, safely, and sound. And just like the postman in our analogy, TCP requires splitting large data into smaller units called packets, which is conveniently similar to the word package, and sending that data through a network of intermediary machines to you, all the while running a set of very detailed checks and balances to ensure timely and correct transmission. Now, within the lingo of TCP and within the context of web development more generally, you're often going to hear references to terms like client and service, or client and server, I'm sorry. A server is just a machine that's sending the information. In the postal analogy, you are the server because you're serving your grandmother some apples. And a client's the machine that's receiving the information. Just like people tend not to send random unsolicited barrels of apples to each other, servers too tend not to send information unless they receive a formal request. And the machine equivalent of that letter from your grandmother asking for the apples is called a request. Now, after receiving a request, a server can choose how to respond, i.e., should it send the apples or should it not in the analogy. And to be clear, the terms request and response are things that you're going to see in the web development lingo as you look online, review forums, and explore far beyond this class. And just as there are social protocols for requesting things from people, you can say please, you say thank you, you don't talk when other people are talking and so on, so too are there protocols for how to make requests and issue responses when you're using the internet. And the details of how those requests and responses are structured is through something called the Hypertext Transmission Protocol, or HTTP. Everything that I've mentioned up till now is just to give you an analogy of how this technology works. What we're going to be doing in the lecture today is going into each of these in a lot more detail and trying to prepare you and equip you with all of the terminology you're going to need as you hit the ground running on the actual nuts and bolts of implementing full stack web applications starting next week.